June25, a 3 ohm resistor and a 6 ohm resistor are connected in parallel across a 9-volt battery. Which statement best compares the potential difference across each resistor? Okay, let's draw a picture of this circuit. So we have a 9-volt battery. It's a good idea to start with the voltage source when you're drawing circuits. And for a battery or a voltage source, we use these two parallel lines where one is a little longer than the other. The idea is that the positive charge comes from the longer plate and the minus comes from smaller, and the voltage is 9 volts. Alright, so that's our battery. And then there are two resistors that are wired in parallel and connected to that battery. So how do we draw that? Let's draw a line across and a line across, and then we'll come down halfway in the middle and put one of our resistors there, and then we'll come down over here, put another one of our resistors there. Alright, so why don't we say that this is the 3 ohm resistor, and the symbol for ohm is capital Omega, Greek symbol. So those are the resistances of the resistors, and this is the voltage of the battery. And they want to know which statement best compares the potential difference, which is just another word for voltage, right? So which statement best compares the voltage across each resistor? Well, the voltage coming out of the battery is 9 volts. So that means the potential at this node here, just outside of that where it's sending the current around, is 9 volts. And that at this plate where it's coming back as 0. So think of this as 9 and this is 0. And as it goes around the loop, somehow things happen to it. It goes through resistors, right? And the voltage drops, and then it comes back around and all the voltage has been used up. So that's kind of how to think about this. So unless there's a resistor, the voltage doesn't change. So if it's 9 coming out of here, it's still 9 up at this node, and it's still 9 when it gets to here, and it's still 9 when it gets to here. So by the time it actually goes through the resistances, it starts out as 9 at both of these nodes right before the resistors. And the current is traveling like this. And then when it gets to the bottom, there's no other resistors to fall for it to go through besides the 3 and the 6. So this node, which is 0, is the same as, has the same potential as this node, which is 0, has the same potential as these nodes, which has the same potential just on the other side of the resistor. So another way of saying the same thing is there are 9 volts across each of these resistors, and that's part of a characteristic of them being wired in parallel. So the best choice is 1. If they were wired in series, just to show you kind of quick what that would look like, you'd still have your battery, and then instead of, you'd have one of your resistors here, and then without it passing through, so instead of it being these two independent legs, it would have to pass through the 3 ohm before it passed through the 6 ohm. And we would say this is wired in series, and the voltage drop across each resistor in this case would be very different, and we'd have to use some other calculations to find out what that is. But in parallel, it's pretty easy.